Have you ever wondered where stars come from? How they're born? The story begins not with a bang, but with a whisper, in the cold, dark corners of the cosmos, where clouds of dust and gas float in the interstellar medium. These clouds, known as nebulae, are the true cradles of stars. In these nebulae, something remarkable happens. The very stuff of the universe, particles of dust and gas, begin to coalesce. The invisible hand of gravity pulls these particles together, drawing them into a swirling dance of cosmic proportions. As more and more material gathers, the center of this dance grows denser and hotter, forming a protostar. This is the embryonic stage of a star, a stellar seedling, if you will, hidden within a cocoon of dust and gas. Now, the real magic begins. As the protostar continues to grow, the pressure and temperature at its heart rise, setting the stage for a grand spectacle. When the core temperature reaches about 10 million degrees, a process called nuclear fusion begins. This is the heart of a star, where hydrogen atoms are squeezed together under immense pressure to form helium, releasing an incredible amount of energy in the process. This energy radiates outward, providing the star with the pressure it needs to resist the inward pull of gravity. The moment nuclear fusion begins, the protostar graduates to become a true star. This is the birth of a star, a moment of celestial transformation, where a simple cluster of dust and gas becomes a beacon of light and life in the universe. From this point forward, our star embarks on a journey of stellar evolution, living out its life by burning hydrogen and producing light. The details of this journey depend on the star's mass, but that's a tale for another time. So that's how a star is born, starting its journey in the vast cosmos. From humble beginnings in a nebula to the blazing glory of a true star, each celestial body has a unique and fascinating story to tell. Now that we know how stars are born, let's explore how they live. Imagine a bustling city in the heart of rush hour with energy flowing ceaselessly. This is the life of a star, specifically its main sequence stage. This is where a star, like our sun, spends the majority of its time, bustling with energy. Stars are not just glowing orbs in the sky, they are nuclear powerhouses. At their core, they carry out a process called nuclear fusion. This is where the magic happens. It's like a cosmic dance, where hydrogen atoms under immense pressure and temperature come together to form helium. This dance releases an enormous amount of energy, which we see and feel as light and heat. Our sun, an ordinary middle-aged star, has been performing this dance for about 5 billion years, and it's expected to continue for another 5 billion years. That's a lot of time, isn't it? But here's a fun fact. Not all stars are created equal. The size, color, and temperature of a star depend on its mass. Let's start with size. A star's mass determines its size. The more massive a star is, the larger it tends to be. But size isn't everything in the universe. Next, we have color. Stars come in a variety of colors: red, orange, yellow, white, and even blue. This color is a direct reflection of their temperature. Cooler stars are red or orange, while the hottest stars are blue or white. Our sun, with its surface temperature of about 10,000 degrees Fahrenheit, is classified as a yellow dwarf star. Temperature is crucial in a star's life. It's the oven that bakes the cosmic cake, so to speak. The higher the star's temperature, the faster the nuclear fusion process, and the more energy it produces. Then there's the question of lifespan. You might think that the larger the star, the longer it lives. But in the stellar world, it's quite the opposite. Larger stars have shorter lives. They burn through their fuel at a much faster rate than smaller stars. So, while our sun can live for about 10 billion years, a star 10 times its size might only live for a few million years. In this cosmic dance, stars keep changing throughout their lives, but one thing remains constant: their ability to generate energy. It's this energy that makes life on Earth possible. It warms our planet, drives our weather, and powers the photosynthesis in plants. Thus, the star continues to shine, illuminating the universe with its energy. Everything that begins must end. But how does a star, with its immense energy, meet its end? Just like us, stars have a life cycle. They're born, they live, and they die. But unlike anything we see on Earth, a star's death can be a spectacular, universe-altering event. Let's delve into the mesmerizing and dramatic finale of a star's existence. When a star exhausts its nuclear fuel, it's like a car running out of gas. It can't go on. The energy it's been producing to resist gravity diminishes, and the star begins to contract under its own immense weight. But here is where the tale diverges, depending on the mass of the star. Let's first consider a small to medium-sized star, like our sun. When our sun has used up all its hydrogen fuel, it will expand into a red giant, swallowing up the inner planets, including Earth. But fear not, this won't happen for another 5 billion years or so. Eventually, the outer layers will drift away, creating a stunning cosmic spectacle known as a planetary nebula. What remains at the core is a white dwarf, a dense, hot stellar remnant about the size of Earth. Over billions of years, the white dwarf will cool and fade, becoming a black dwarf, an endpoint so distant in the future that no such object yet exists in our universe. Now let's turn our attention to the death of a massive star. When a star much larger than our sun runs out of nuclear fuel, the drama amps up. The core collapses under gravity, triggering a tremendous explosion known as a supernova. This cosmic event is so bright that it can outshine entire galaxies for a brief moment in time. But what happens to the core of the star post-supernova? Well, it depends on the star's mass. If the core is about 1.5 to 3 times the mass of our sun, it becomes an incredibly dense object called a neutron star. These stars are so dense that a teaspoonful of their material would weigh as much as a mountain. However, if the core is more than 3 times the mass of our sun, not even the pressure of neutrons can hold back gravity. The core collapses completely, forming a black hole, a region of space where gravity is so strong that nothing, not even light, can escape. Supernovae are not just awe-inspiring spectacles, they are also cosmic factories, forging heavier elements like gold and platinum. These elements are flung out into the universe, becoming part of interstellar clouds that can form new stars and planets. In a way, we are all made of star stuff, as the elements that make up our bodies were once in the heart of a star. And so, a star concludes its epic journey, leaving behind a legacy that can span billions of years. From the humble white dwarf to the terrifying black hole, a star's death is a cosmic spectacle of immense proportions, a testament to the grandeur of the universe that surrounds us. The life cycle of a star is a captivating tale of cosmic birth, life, and death. It's a story that unfolds over billions of years, beginning and ending with spectacular cosmic events that shape the universe as we know it. Our journey begins in the expansive, gaseous nebulae, where stars are born. Clouds of dust and gas, primarily hydrogen, begin to collapse under their own gravitational pull. As these particles come together, they create a protostar, the embryonic stage of a star. Over time, as the protostar accumulates more mass and its core temperature rises, nuclear fusion begins, and a star is born. The bulk of a star's life, known as the main sequence, is spent burning hydrogen in its core. This process releases vast amounts of energy, which is emitted as light and heat. Our own sun, a middle-aged star, has been in this stage for about 5 billion years and will continue for another 5 billion or so. But even stars can't last forever. When a star exhausts its hydrogen fuel, it begins to swell and cool, becoming a red giant. The core collapses further, heating up and triggering fusion of heavier elements. The exact fate of the star depends on its mass. Stars like our sun will shed their outer layers, leaving behind a white dwarf, which will eventually cool and fade away. However, more massive stars meet a different fate. They explode in a supernova, a stellar event so powerful it can outshine an entire galaxy. What remains could be a dense neutron star, or, in the case of the most massive stars, a black hole. In the grand scheme of the universe, stars are but fleeting sparks of light, but in their short existence, they play a crucial role in the cosmos, illuminating the dark, creating elements, and in their death, sowing the seeds for new stars to be born. Before we close, let's take a moment to appreciate the impact stars have on our lives. The light they emit not only illuminates our night sky, but also provides the energy necessary for life on Earth. The heat from our sun drives weather patterns, photosynthesis, and even our own biological rhythms. Moreover, the elements that make up our bodies and our world were once forged in the heart of a star. It's a humbling thought, isn't it? We are, in a very real sense, made of star stuff. The death of a star is not an end, but another beginning. The explosion of a supernova spreads these elements across the cosmos, seeding future generations of stars and planets. And who knows, perhaps somewhere out there, in the swirling gas and dust of a distant nebula, a new star is being born at this very moment, ready to begin its own cosmic journey. In the grand tapestry of the universe, we are all connected. Through the life cycle of a star, we've witnessed the universe's ability to create, destroy, and recreate over and over again. It's a cycle that's as beautiful as it is profound, and it's a reminder that even though we may seem small in the grand scheme of things, We are part of something much, much bigger.